Let's try this more challenging graphing question involving lines. We have 3 points, A, B, and C. Point Q is on line AB, and CQ is perpendicular at 90 degrees to line AB. What are the coordinates of point Q? It's a good idea to sketch a diagram here. So we have these points all sketched out. We draw some lines, and we can see what the question is asking for. Point Q is on line AB right here, and CQ is perpendicular to AB. So this is a right angle. What are the coordinates of point Q? So we're trying to find the exact coordinates of where these lines intersect. Now, to find where lines intersect, it's a good idea to find the line equations. Can we find the line equation of this line AB, the red line here? And the key is that we have 2 points, so this shouldn't be too hard. The slope of AB equals rise over run. So I'm going to just subtract the y values. -2 minus 0 over the run, 1 minus 5. We get -2 over, and pardon me, I just noticed that there should be a negative sign here. So this should be a -5 here. So this is going to be 1 minus -5. Let's just change that up a little bit. So we get -2 over 1 plus 5 is 6. And the slope here is -1/3. And the reason why we caught this is because we visually double checked. Downhill from left to right means it should be a negative slope, and this is great. So we found the slope AB. So now, because these lines are perpendicular, we know that the slope of the other line of CQ is going to be the negative reciprocal of -3 over 1, which is 3. 3 over 1 is 3. And so when we think about this blue line, line CQ, we have a slope and we have a point. This is enough using slope point form. Y minus y1 equals m, x minus x1, that's slope point form, line equation. And so our y value is 3. Y minus 3 is equals to m, which is 3, x minus -2. So we have minus -2. And so we have this line equation. So let's work it out here. We have y is equals to 3, x plus 2, and plus 3. This -3 goes over here, plus 3. So let's continue. So we're talking about this blue line, line CQ. So line CQ is 3x plus 6 plus 3, which is 3x plus 9. So this is y equals 3x plus 9. We're talking about line CQ. This is the line equation. Now let's finish off the other line equation. For the previous line equation, we had a slope of -1/3, and we have a point. I'm just going to use point A. So y minus y1, let me just change colors here, is equals to mx minus x1. So for this red line, I'm going to choose y minus this point here, -2 is equals to m, which is -1/3 x minus 1. So we have y plus 2 is equals to -1/3 x plus 1/3. Going to subtract 2 from both sides, minus 2, which is the same thing as minus 2 is the same thing as minus 6 over 3. And so the second line equation, 1 minus 6 becomes -5 over 3. -5/3. So this here is the second line equation. This here is line AB. Now to finish off here, we want to find the point of intersection, so we set the two equations equal to one another. We have the same y values, so we can equate the other parts. So if I say that -1/3 x minus 5 over 3 is equals to this part here, this other line, 3x plus 9, we have this nice equation where we only have one unknown variable x. We can solve for x. I'm going to multiply both sides by 3. So I got -x minus 5 is equals to 9x plus 27. And I'm just going to move this over here. So we get 10x is equals to -5 minus 27 is equals to negative 32. So divide both sides by 10, we got x equals negative 3.2. Now we could have also kept this as a fraction and reduced it, but in this case we'll just be satisfied with decimal numbers. So once we have the x value, you can plug it into any formula to solve the y value of this point Q. So I'm going to plug in this x equals negative 3.2 into this equation here, because this one looks pretty simple. So I'll say y equals 3, negative 3.2 plus 9. Using our calculator, we get y is equals to negative 0.6. So our point Q is actually negative 3.2 x value, and the y value is negative 0.6. And when I visually inspect these numbers and the likelihood of it being true, it looks pretty on right there. Now this question is a bit tricky because it requires you to understand what the question is, and as long as you can draw the actual points and get a sense of what you're trying to do, in this case we're trying to find the exact coordinate of point Q, we need to find the two line equations and set the equations equal to one another to solve for x. And once you have x, you can plug into any equation to solve for y. Now if this question was more forgiving and it actually asked for any point Q on this blue line as opposed to exactly where they intersect, then all we need would be to find the slope of this line, which we did previously by doing the negative reciprocal. And if we have this point here, negative 2, 3, and we have a slope, we can simply count doing rise over run. So the idea of using rise over run to find some other point on this line would also apply. So we could solve for many different point Qs that are on this line. And the idea of rise over run applies to the going down left or up right as well. So don't feel bad if this question is a bit tricky. Just take heart that these graphing type questions are questions that students struggle with. And as long as you practice enough, sketching, working out the algebra reliably, understanding what you need for a line equation, understanding that these questions only change so much, whether you're talking about perpendicular versus parallel, you'll master it one day. Hopefully today. Good job.